This assessment asks us to give two possible alcohols that would give the same alkene product under dehydration conditions, noting that one of them will occur with rearrangement and one of them without. Let's do the one without rearrangement first. Here we have an alkene. The alkene that we're going to form is probably going to form through this tertiary carbocation. Recall that if we had this tertiary carbocation, in the next step, we would remove one of these protons to make the most substituted alkene here. So when we're thinking about what alcohol we want to start with, it needs to be an alcohol that can make this tertiary carbocation. And so let's just put the alcohol itself, the hydroxyl group, on that tertiary carbon. If we had this and we protonated it, we'd make a good leaving group. It could leave to give us this carbocation. Now, when we think about the one that has a rearrangement, we have to think what carbocation might rearrange to give this tertiary carbocation. We could imagine that carbocation being here or here. Both of those would be primary, so we really don't even want to think about forming a primary carbocation. So probably the carbocation would instead be at the secondary carbon. And so we can imagine that if we made this carbocation would undergo a hydride shift to give this one. And so this tells us that we want to have our hydroxyl group at this position to give the alkene after rearrangement. And so, for example, if we started with this alcohol, we could once again protonate it, make a good leaving group. It leaves, gives us this carbocation, and now rearrangement occurs to ultimately give the more substituted alkene. So these are the two alcohols we start with. This one would give the alkene without rearrangement. This one would give the same alkene, but with rearrangement.